So, hi, welcome, all of you.
Hey.
So, I really enjoyed the previous talk about the multi-platform. Like, it kind of has really great potential. So, hopefully, we'll be able to use it soon in a lot of apps.
Yeah, and this is Igor, lead developer on this project.
So this is Natalia. She is helping with the Konsist maintenance. So we are basically the team Konsist. Before we start, few things worth mentioning. So there will be some time for the Q&A at the end of the talk. And my kid was playing with my computer, so it may behave strangely recently. So let's see. So nowadays, projects are often complex. And this complexity is often the result of like inconsistent, tangled, and messy code base. And the poor code base quality is often consequence of the constant changes within the code during the project lifecycle. So as the project grows, as we add new feature like fix bugs, add some patches, that quality of the code tends to degrade. So, there are obviously more factors that are affecting the project code quality. So time pressure, lack of testing, no documentation, or lack of proper documentation. So all of these factors are compromising the code quality, like basically making it less friendly and a bit more difficult to work with. That's why nowadays the linters are quite handy. So linters are vital during the software development. They basically analyze the code without running it. So there are multiple pros of using linters, but like to keep it simple, they enforce coding standards in the project, help to write better code, follow good practices across the code base. So several linters are already available for the Kotlin programming language. So let's see what's there. So we have like 3 established linters. One is Detect, the other one is Kotlin, and Android lint, mostly known for Android devs. So all of these linters, like some of the rules in these linters may overlap a bit, but each linter has a like unique pronounced purpose. So for example, if we look at Detect, then it's focused mostly on like potential bugs, like performance issues, identifying code smells, like encourage code simplifications, detect potential error-prone patterns. For sample rules here may be too many parameters in the constructor, some complex conditions in the method, or simply methods that are too long. So Kotlin focus, on the other hand, is the mostly about code style conventions. So it enforces like unified coding style in the project. So to kind of provide you organized, well-maintained file structure. So you may have rules like import ordering, max length of the line, or for example, like new line that is required at the end of the file. And then the Android lint, obviously, so it's lint like focused for Android, where we can catch potential bugs, performance issues, like compatibility problems. So for example, it detects whatever or not the code is compatible with different Android versions, which is usually a pain for us Android developers, identifies places for app speed improvement, for responsibility improvement, and encourage the correct usage of Android APIs. So with this, with all of these tools, you may wonder like why we need another linter, why we need Konsist, right? So let me tell you this. Oops. Okay, sorry, do you have a charger?
No, I don't have, but I will try fix this. Let me drag it here. Ta-dam, it works.
Okay, your turn.
Meet Jane. Jane has always been passionate about coding, and the opportunity to work as a Kotlin developer was her dream. And finally, one day, that day arrived. She had now joined the thriving tech company, eager to contribute her skills and learn from her talented colleagues. A few days into her role, Jane was assigned her first task, adding a new use case to the project. Excitement bubbled within her. This was a chance to prove herself and make a meaningful impact. The task seemed straightforward, but she wanted to make sure that she aligned her work with the established patterns of codebase. So Jane began exploring existing use cases, opening file after file and digging into the project structure. She expected to find some consistent pattern, something that would guide her in crafting the new use case. But what she found was concerning. At first glance, these use cases looked similar, but after closer examination, she noticed that the use case class declarations were inconsistent. In Jane's exploration of the codebase, she noticed an intriguing pattern, the diversity in the class naming conventions. Some use cases had no suffix, others had the use case suffix, and there was even one class with the UC suffix. Another confusing issue was the naming of the core methods as they varied in each use case. The most common ones she found were invoke, but she also noticed execute and run. The number of public methods also varied in each use case. Some use cases had one public method, which was fine. However, some had a few, which is most likely a code smell. There was one more thing that really confused her. The visibility modifiers of these use cases were also different. Some had an explicit public modifier defined in the code. Others had the implicit public modifier, as that is the default visibility modifier in Kotlin. The rest were private. But that wasn't the end of her concerns. There was also a difference in using the operator modifier in methods. While the most methods didn't have this operator modifier, there were some that did. Jane made a high-level summary, but it left her even more lost and confused about coding standards and established code-based patterns. She realized these use cases were written by different developers, prioritizing their own personal opinions rather than the project-specific standards.
So Jane decided to explore the Konsist to the new cutting-edge structural linter to started writing simple tests to learn how the Konsist works to help her with code-based unification. So Jane learned that on the high level, Konsist test follows very simple structure. So she needs to create the scope, then filter the desired declarations, and finally define the assertion. So let's take a closer look at each of these building blocks.
Scope creation is the first step in writing the Konsist test. Scope represents a set of Kotlin files to be verified by Konsist test. The scopes are created during the test run, ensuring they cover all latest Kotlin files present in the project. The entry point for the Konsist framework is the Konsist object, and various methods can be used to obtain instances of the scope. The widest scope is the one containing all Kotlin files present in the project. It's also possible to create more granular scopes to fit the project needs. For example, we can create scopes from each module. This may be helpful, for example, when we are refactoring project module by module or when specific checks are laid for the given module. We can go even more granular by creating scopes from individual source sets using the source set name. Often, we want to check only the production code, and Konsist allows us to create such scope. Konsist supports also Kotlin operator overloading, so scopes can be further combined together for desired scope tailored to the project needs. For example, scopes can be combined using the plus operator. However, these are not all possibilities for creating the scope. Check the Konsist documentation for more examples.
Yeah, so we have a scope. So now the next step is like filter the desired declarations we want to check or verify within our project. So, for example, we might want to filter the classes, and Konsist API provides dedicated method for class retrievals. These functions usually return a list of KO declarations, probably of the more specific type. So, because this is a list, we can use Kotlin collection processing to filter these entities. So in this example, you can filter all the classes where name ends with the repository. However, this syntax is quite verbose, and because like consist has very specific usage, there are dedicated consist methods to actually simplify these checks even more. So, for example, we have this with name ending method. So, consist provides set of handful extension functions to simplify the usage. So let's take a closer look at that. Okay, what's next? Okay, we need to fix the brightness. Okay, where was it? Okay, we need to find the switch. I'm pretty sure it was somewhere on the right. No, maybe at the bottom. Oh, okay, I know where it is. It's here. Okay, I have it. So just mark the switch, and we should be able to go. So, thank you. Yeah, I really need to stop. I need to ask my son to stop playing with this computer. So basically, in fact, we can filter these declarations in very quite flexible way. So for example, we can filter all of the annotations that are present in the code using single consist method. In a similar manner, we can filter declarations with certain type of modifier, like internal in this example. We can also, query things like secondary constructors or primary constructors, and obviously the parent classes. So as you can see, these methods are chained, so it's similar to Kotlin collection processing, where you can launch set of granular methods to filter all the declarations that you want to check. Obviously, these methods also have additional overload with the lambda, where you can have even more control on the filtering, and we have without equivalent to do a negative filtering. So let's look at another example here. So this time we will work with functions. So basically this will allow us to query all of the functions that are present in the project. So for example, we can filter functions that exist within certain package, or that have only the expression body, or that have certain parameters, for example, here of type service. So this would give us like all of the functions where function has parameter of type service. So obviously, we can also check the return type, etc. So we have the scope. We filter the declarations. So now the final step is to define the assertion. So Konsist API provides a set of properties to basically allow you to retrieve the information about declarations existing in code. So for example, we have a name property where we can get the name of the class, the constructors property. We can have properties property, which is a bit abstract, but basically it will give you a list of all the properties within a given class in this example. We can filter functions in similar way. So on top of that, these declarations have additional method to check simple things. Is the function the top level, or maybe has it certain kind of the modifier? So these are typically more handy when writing assertions to verify things. So to create assertion, basically you will use one of the assertion methods. So most likely it will be assert true, which will provide you the lambda where you can actually write the assertion. So in this case, we filtered all of the classes that has name ending repository, and we are checking if all of them reside in the repository package. So notice these double dots before and after the repository. So basically, it's a syntax to say this is repository package followed by any number of packages and existing like within any package. However, you can tweak it more to your needs. So maybe you can have like com your application name .repository, and then any number of the packages that follows that. So it's important to know that this actual check is performed on all of the queried classes from the upstream, all of the queried declarations. So it's not only single class instance, but like all of them. The other thing to notice is that this last expression determines the outcome of the test. So for more complex tests, where you may add more lines to the lambda, the final one will be used to determine whether or not the test has failed or succeeded. So basically, the idea, behind the consist and the true power of the consist as opposed to other linters is like, decides what are your coding standard in your code and actually write the custom checks to verify this code and like kind of guard this code structure for the future. So probably like a lot of you are working with detect and KT-link, so at this point you are able to see that the checks that we just created are impossible or very hard to write using these conventional linters. So, and obviously you may wonder, how we have this consist test. So now the question is how would we run this test, right? So we basically run it by wrapping this in JUnit test, and this is it. So obviously we can do the same with the KO test. So in KO test we wrap this in KO test lambda. In JUnit it just wrap it in JUnit method. And obviously because this is kind of the library that requires dependency, so we need to add the consist dependency into the test source set, as well as your the test framework dependency of your choice.
And after learning about Konsist and aligning with the team, Jane decided to unify the code base and enforce coding standards across the project.
Yeah, so we have all of this theory. So now let's see how Jane managed to fix her project to unify the code base. So in every project, rules for the use case may vary. So in Jane's project, this is simply a class that is defined inside use case package. However, in other project, this may be a class that is annotated with certain type of annotation, or perhaps the class that exists in certain module or with certain inside given layer. So Jane decided to write her first consist test. So she as usual, writing unit test, she wrote a test with a given name, and then she decided to start writing consist. So consist keyword is the entry point to the consist framework. Then Jane created the scope from production code, queried all of the classes, and as we said, she created the use cases according to the project standards. Then it was just a matter of writing a simple assertion to verify if if every class that exists in the use case package has the name ending with use case. And obviously, the test has failed, which was fine in this case, because we have code base that we need to fix. So in this example, the fix was quite easy. It was just a matter of renaming two classes to add the suffix to the use case name. And the first test was passing. So then Jane decided to look at unifying the naming of the invoke methods. So similar as before, she created a scope, queried the classes, filtered the use cases, and asserted the conditions. So in this case, she basically made sure that every class has a function with the name invoke. So as previously, the test has failed. So it was another time for the code base update. So in this case, it was also a simple change of renaming the methods from execute to invoke and from run to invoke as well to unify these use cases. So another consist test was passing successfully. So because Jane noticed that some of the things in the test were duplicated, so Jane basically decided to extract the scope representing use case classes into a separate variable and use this variable inside the test just to simplify them and make them easier to read. So another thing that Jane wanted to check was if every Kotlin class has the operator modifier. So Jane, this time, instead of writing new test, she decided to update the existing one. So she obviously changed the name of the test to reflect what the test is doing, and then added an extra condition, has operator modifier, to check if the invoke function that we know should exist or also has the operator modifier. So another test has failed as expected. So it was time to fix the code base. This time it was also another simple fix where basically we added operator modifier to all the use cases where it was missing. So another test was passing successfully. So with our use case verification, another useful thing to do by Jane was to check if the use case has a single public method, because as we know, like for the use case convention, most likely it should have only one. Otherwise, it's probably some kind of code smize, as use case represents single piece of logic, business logic. So in this case, Jane write assertion to count number of functions within the code, and use like has public or default method to see if the modifier exists. Like notice this like method in particular, because as we know in Kotlin, we may have explicit public declaration, or most likely the implicit one, as public is the default one. So another test has failed. So it was time for another fix. So this time, Jane added the private modifier to one of the use case function, and the other use case was matching the project code conventions. So another thing that was inconsistent in the project was the use case class visibility. So it was time to write the final test. So Jane wanted to make sure that every use case class is actually public. So as you see that the check was also quite similar and quite simple. And obviously we got another failing test. So it's typical, path of red-green basically refactor when writing test. So fix was simple as before. It was just a matter of removing one of the modifiers from the class. So doing all of this basically allowed us to unify code base, but we unified this code base in a kind of way or standard decided by the team. So the good thing is that the structure of this code, will be automatically guarded while running Konsist test with each PR. So your code quality of your code base will not degrade over time. So obviously, as I mentioned, those use cases may have different structure in different projects, but as you can see, like Konsist got you covered. So Konsist API like reflects all of the constructs in the code, so they are quite easy and intuitive to use. Keep in mind that in isolation, every single of these changes may look insignificant and small and unimportant, but in typical project, like when you combine tens or hundreds or maybe even thousands of these kinds of changes, this is what actually makes the code base quality messy.
Besides declaration checks, Konsist provides a way to verify architectural layers. So let's discuss this feature using a simplified version of clean architecture. So let's look at these three layers: the presentation, data, and the domain one. And we want to, of course, ensure that the presentation and data layer depends on the domain one, and the domain layer depends on nothing. So let's write a Konsist test for this architecture. As with declaration checks, the first step is creation the scope. And then we have to use the assert architecture block to define architecture layers rules and verify that the layer requirements are met. Next, we have to represent project layers by creating instances of each. Each layer instance requires a name, which is using for presenting architectural violation error, and a package to define this layer. Including two trailing dots indicates that the layer includes this package and all of its sub-packages. And finally, we have to define the relations between each layer. In our case, is the domain one depends on nothing, presentation layer depends on domain one, and data depends on domain two. This checks is extremely helpful when multiple layers are present inside a single module, and thus layer dependencies cannot be verified by the build system. Importantly, this feature is still build polished. It works, but we have received the community feedback to add some new features and improvements.
Yeah. So I mentioned before that there are 3 linters in Android or Kotlin ecosystem, but actually there is a 4th one, like called ArcUnit, that you may be familiar with. So, okay, loading. Okay, we don't need this one, right? So let's remove, we don't like loadings, bye. Um, so, so there is the fourth one called ArcUnit, which basically is a bit similar to Konsist, because it also focuses on like code, like some actual architecture pattern and some declaration consistencies, some layer boundaries. So at first glance, they may look similar. So like it's important to take a closer look why we decided to craft Konsist. So the main thing is that ArcUnit may be an effective solution for Java project, but it fails short when it comes to Kotlin. So at high level, you know, we have Java source code or Kotlin source code that is compiled by a compiler to the JVM bytecode, and ArcUnit works at the JVM bytecode level. It means that it analyzes the bytecode that was generated to provide the check. So obviously this feature has some drawbacks when using with Kotlin, because crafting Kotlin-specific checks is challenging or sometimes nearly impossible to write. So if we consider check, like for example, if, like in our use case example, does the class has a single method, right? So this check works fine for method without any parameters. So in JVM bytecode, this method is represented also as a single method. However, the same check becomes problematic when we use Kotlin-specific features like default arguments, because then in JVM bytecode, this method will be represented by multiple methods. So as we know, Kotlin compiler employs extensive code generation to accommodate constructs that are not inherently supported by JVM bytecode. That's why we have those three methods, and obviously there is a chance it will change over time. So there is no guarantee. So Kotlin source code may actually manifest in multiple declarations in the JVM bytecode, and this sometimes is a bit unpredictable. So that's why, from ArcUnit perspective, this single method check will fail. We see the single method in the code, but ArcUnit will see more. Another example would be like filtering the declaration. So if you want to write a simple test, let's say, does every class has a test, right? Which kind of as idea is very nice things to check. And this works mostly fine until we realize that we want to exclude certain types of classes, like we want to exclude data classes or value classes, right? And because those are, again, Kotlin-specific constructs not known to JVM, the ArcUnit will fail. So Konsist works a bit differently. So Konsist works at Kotlin source code level. So it supports all of the Kotlin declaration by design. So actually, we are using Kotlin compiler dependency to kind of parse the Kotlin code, so we know that it's always up to date and it will be always updated. So we just kind of we can think about Konsist that is a wrapper around this library, obviously with more than a few lines of code. So it works natively basically with extensions, default arguments, data classes, companion object, etc. So this approach of parsing the Kotlin code directly helps with verification of Kotlin multi-platform. So on a high level, the Kotlin code can be compiled to multiple targets, JVM bytecode, JavaScript, and like native codes, like usually through LVVM. So when we look at the comparison, the ArcUnit will obviously work with JVM and bytecode, but you will not be able to use it with anything that basically is other than JVM. So basically, most of the modern multi-platform targets we will see coming these days. So another pain point of using ArcUnit is the API. So consider the simple ArcUnit test. That looks simple, few lines of code, similar to the Konsist. However, there is a catch, and the catch is that these have one public method with name, operator extension. Is a custom implementation. Like, don't read this code, just get the idea about the amount of code. So most of the developers, like including me, who I talked about ArcUnit, like the moment you start to use it, the moment you need something custom, you need to learn the ArcUnit API that is often quite complex. You need to understand a lot of concepts, so the learning curve is quite steep. And obviously, maintaining this is another story, because we write this test, leave it for a few months, and then if it breaks, someone needs to kind of figure this out again. So that's why, in general, like ArcUnit is harder to use and harder to use with the Kotlin, because these simple checks might require some verbose code. So few concepts like that may be helpful when working with Konsist. So Konsist, using the Kotlin compiler to create set of declarations from the code. So obviously, that at the highest level we have the scope that usually contains the Kotlin files that may contain other declarations, like classes or functions that you need to query using the Konsist API. And it kind of the whole core idea here is that, like, if you see it in the code, on the Kotlin source code of your project, you should be able to query this in Konsist. And at this time, we have really high level of kind of matching most of the stuff that's in the project. So if something is missing, obviously, please let us know. So when writing initial Konsist test, you may need more visibility mostly to understand what's going on. That's why we introduced some helpful methods. So for example, with the chain method, you have a dedicated print method that prints all of the declarations to your console. Obviously, you have some arguments, so you can add some suffix to help you with the filtering, or you can use lambda as an argument to actually provide even more specified logs. Obviously, this works with the chaining, so you may filter some declaration, print them on the console, filter them again to understand what's going on. However, the best tool I find, like, to debug this test is actually the evaluate expression. So we know that we can put the breakpoint in the code, right? We can debug the test. I hope everybody knows that. And then we can run this evaluate expression that is extremely handy, because it allows you to execute code, any custom code, at the moment of your breakpoint stop. So this means that basically you can enter the Konsist test and just evaluate this and see the results. So this helps immensely with the filtering content and understand what code is returned by the Konsist APIs. So another thing that may be handy are the dynamic tests. So consider these three classes. So let's assume we have simple project with 3 use case classes, which will never happen, but it's there. So so basically, we will write two Konsist tests. Like, we don't care about the body of this test, so we just write 2 tests. So if we execute this test using our testing framework, most likely we'll use static tests. So single test will contain checks for all 3 use cases. So that's why we have two tests written and 2 tests visible in our output. However, it's possible to configure the Konsist with the dynamic test. This is provided both by JUnit and KO test. So then every single use case will be represented as separate tests in your test reports, in your IDE, in your CI pipeline logs. So this way you will get a bit more visibility. So I will not get into details how to set this up, but just check the Konsist documentation. We have a dedicated page. Also, you do it once and it's super helpful.
Yeah, and let's look at the state of the Konsist project. Konsist is quite extensive, with about 180,000 lines of codes. 1,000 pull requests have been closed. We have successfully managed 10 library releases, each packed with extensive features and bug fixes. People seem to like what we're doing. We've got 900 stars on the GitHub. We got a lot of positive feedback from our community, which has over 150 members. The Konsist team has over 50 contributors who are all in on making Konsist great. Whatever they write, commit pull requests or write articles, their involvement keeps us moving forward. And Konsist boasts an extensive documentation spanning over 150 pages. The extensive documentation covers all Konsist features, including detailed explanations of its APIs. Documentation provides practical examples, a set of code snippets, and few advanced topics. For example, we have Android snippets with some tests verifying ViewModel structure. For example, we have some tests dedicated for Spring developers and others. What's more, we have some example of tests using KO test framework and many, many more. Konsist offers smooth integration with leading testing libraries executing Kotlin code. Konsist has first-class support for the JUnit 4, JUnit 5, and KO test. Konsist also supports various project types, including Spring, Android, and Kotlin multi-platform. Konsist is compatible with popular build systems such as Gradle and Maven. The Konsist has undergone extensive field testing across various projects, what you can see on this slide. You don't have to read this, it's just an example of checks before each library release. For instance, one check is a thorough testing system with about 5,000 tests. Another few are for separate projects will help with testing specific features. The next one contains a custom checks in the form of the Python scripts to verify Konsist artifacts. And above all, Konsist is used to verify the Konsist codebase. Yeah, I will give you a moment to process this. Konsist is not at version 1.0 because we still want to polish its APIs, particularly focusing on the architectural checks. Importantly, the Konsist code is only the part of the test source set, similar to JUnit, where the library code is not included to the application release code. This ensures that Konsist is safe for use in commercial projects. In the worst-case scenario, the Konsist test failure will never break the production code.
So we have presented a few simple examples for you. So you should get the idea by now how the Konsist works and how it can help you if maintaining your code base and make it cleaner. So few takeaways. So it's new structural linter like created for Kotlin, dedicated for Kotlin, and compatible in Kotlin ecosystem, and obviously written in Kotlin. This is fully open source project. So if you see a bug or wanna let us know about missing feature, like we are there. It has a flexible API and provides two types of check, like architecture checks and like declaration verification checks. Obviously, it's free to use, and it's safe to use in the production. So where to start? Like the best place to start is obviously our documentation. You will find the link here or on the GitHub project. So getting started section should kick off the writing of the Konsist test. We also have the dedicated section with the snippets where basically we have about 50 examples of the test. So it's good to kind of go through and get the idea what kind of tests you may write. Obviously, you may check the Konsist repository as well if you prefer to learn this way. We also have a dedicated Slack channel at Kotlin Lang Slack, so join us there if you wanna have a chat with us. So I really hope you like the idea and that you see the potential in the Konsist. We are quite dedicated to actually make it better and do it for you, because this was the tool I was missing when I was working on all of the Kotlin projects over these years. If you like this idea, like please give us Git star on GitHub. It's just something that fuels our passion, because we do a lot of stuff, but we feel like we get a bit of feedback, but we know that much more people are using this. So I will share this presentation will be shared on the Kotlin Conf. I will share it on the Twitter. So thank you for your attention, and it's now time for questions. So who wants to start? Thank you.